Thank you and good morning, everyone, and welcome to this webinar, intent-based networking innovations. Right. Uh, Today we'll talk about what is intent-based networking and what are the innovations that has happened in the intent-based networking. Right. So that Cisco is bringing to you. So as we said, right, we will go along. I'll present few slides. If there are questions, please type your questions in the panel, and then we will take it up towards the end of the session. We will do a Q&A session, right? Um, so with that, I will begin. And what I wanted to share today is the first thing is that why is it important to have intent-based networking, right? So why IBN? So intent-based networking is also an IBN. If is called IBN. If you recall that it was launched by Cisco about 2.5, 3 years ago, and it has been a great success so far. A lot of customers have adopted it. If you if you have not, at least many of them are thinking about it, right? Saying that okay, how do I adopt this technology? So what is it and why do we need it, right? So let me just set the background a little bit, saying that, okay, um, there are certain technology trends that we are seeing, right? So all of us are aware that IoT is one of the big ones, right? So every device is actually, or every instrument, every sensor is actually now connected onto the network, right? So IoT is a big thing. And that is where, we see whole influx of number of devices coming onto the network. So we see a huge number of devices, from humidity sensors to temperature sensors to access card readers to cameras. Everything needs a network connection. So that is a big one of the trends that everyone is gearing up for. Second thing is about the next generation workspace. So our way of working has changed dramatically in the last 10 years or so. Now it is more collaborative networking, right? Collaborative working. So we actually we spend more time in a meeting room, and then spend less time at our cubicles, right? So there is a lot of decisions, there's a lot of things that happen jointly. So the teamwork has gone up, and because of which, what happens is mobility becomes a key factor. When I say mobility, it is like Wi-Fi, right? So Wi-Fi becomes, because you need to be mobile. You can take your laptop and move around and present from anywhere. So this becomes this is becomes a key trend now, and most of the companies are adopting that. The third trend is about explosion of user devices. When we talked about explosion of user devices about 3 years ago, it was all about laptops and desktops and the mobile devices, right? BYOD type of devices. But now it has gone beyond, right? So now people are bringing in or wearing a lot more wearables, right? So they're wearing the Fitbit, they're wearing the G Glass or Google Glass, they have the smartwatches. So a whole bunch of, so this is another trend that we should be ready, because like BYOD, these devices would also need connectivity. And on the corporate network, at some point, you will have to allow them, but you have to allow them with security, right? So you have to like that. So that is a big trend that is happening. The other trend that we have seen is programmability, right? So every device has become more and more programmable, right? So you want the flexibility of programming to be available on every device, right? So these are the trends, and IT teams need to be ready for these trends. So they need to be ready. But take a look at this, right? So typical, this is a typical network, enterprise network as of today, and it is complex, right? It is not easy to design, deploy, maintain, um, troubleshoot these kind of networks, right? So they have various devices at various levels, starting from access layer to distribution to core. You have multiple devices doing multiple functions, and you have multiple points of control, right? So this is typical of today's network, and the challenges because of this is that the topology is not standard, right? There are too many variations of topology. People deploy it as they want, right? So there is no standard way of deploying it. IP addressing is a complex thing, right? So every user is now identified with the IP address. So if somebody complains that their network access is slow or their application is running slow, then we ask, first thing we ask is, what is your IP address? And that's how we start troubleshooting. So the IP address becomes very, tied to the entire process. And tomorrow, if the user, changes his IP address or moves to a different floor, um, we have lost that, continuity in the IP address, right? So user has become a different IP address, and we track that IP address. So, so this is a big problem. And segmentation, that is how do we, divide into different VLANs or VNs or whatever, VRFs. So that is a big problem. Um, so the device growth, of course, more number of devices, client devices coming on, that is a big one. And the biggest problem is that everything is done manually, right? So from the network perspective, whether you're configuring a firewall, whether you're configuring a switch or configuring the distribution core switch, wireless device, most of it is done by itself, right? So you have to go into their own CLI and then type something and then get some. This is how it is, and it becomes a very tedious process when you go through a change, right? So you have to make a change to the network, you have to do it at 5 different places or 10 different places. And of course, when you do manually, what happens? You can do errors, right? So you can type in a wrong command, wrong IP address, wrong subnet mask. Um, so that will lead to problem. So this is what, when we did a study a few years back, we came up with this kind of a statistics from our customers saying that, look, 95% of the changes are done manually too, right? So there is no automation. And because of manual, we introduce a lot of errors, right? So there is a human error, and because of which there could be policy violations also. So you don't want to allow certain access to certain group of people, but because you typed in a wrong wildcard mask in the access list, that could be a problem there, right? And a lot of effort is actually spent on network visibility and troubleshooting. Right now, we don't have a very good system to say what is happening on the network today. Our only indication is when the end user calls and says, look, I'm not getting a good speed on Wi-Fi or I'm not able to connect to Wi-Fi, then only we start looking at it. So our help desk starts, ticketing it, and then people start looking why this is this a single user problem? Is it multiple users? Is it entire floor affected? So there is a whole bunch of troubleshooting that we do, and the troubleshooting is all manual, and it takes a long time to find the problem. So this is all the so we had the new things that are coming in, and then there is a complexity in the existing system, right, that we have deployed over the years. So in that's why when we talk about being ready and being ready for digitization, so Cisco came up with this model of saying that what are the different layers of levels of getting ready for the ultimate self-driving networks, right? So most networks are actually in many in the second stage now, manual or semi-automatic, right? So somewhere there we are, and people are trying to move into more of automated and self-driving network, right? So like self-driving cars from Google, self-driving networks would actually would heal itself, right? So if there is a troubleshooting to be done, it can go fix itself. So that is the ultimate aim, but that we are at least 5 to 10 years away from that. But what people are trying to do is move into that semi-automated and fully automated kind of a model. So this is the digital framework that we have come across. And what we have done is that enable you to move towards you know automated and more analytics and all that. So Cisco came up with this architecture framework called DNA, digital network architecture. So this is a framework, right? So this is not a solution. This is not. We say that, look, if you are going to purchase or deploy a new network as of today, then these are the things that you should keep in mind. So this is more of saying that, okay, you should build your solution along these layers, right? So DNA ready physical and virtual infrastructure. So now you have choice of physical infrastructure like routers, switches, or you can also go for virtual infrastructure like virtual wireless LAN controllers, virtual firewalls, right? So wherever it makes sense. So you should have that as the base, and that will provide you the connectivity. But just having connectivity is not the only thing, right? So we have to look at the entire other functionality that the network can bring in. The second layer is virtualization. So virtualization is nothing but segmenting the network or running multiple network within the physical network, right? So not new. So we have been using VLAN, VRFs for a long time. So those are all virtualization, right? So we are running multiple VLANs over the same physical infrastructure. Now, what is new here is virtualization should be dynamic in nature. It cannot be static. You can't say that, okay, these 10 ports in VLAN 1 and it will stay there forever. So if somebody connects from a different department, you have to manually go and change the VLAN of that port. So that is not acceptable. We are saying that you should be able to bring in user-based networking. So user-based, identity-based networking is where you actually say, oh, who's logging in? This is Ved, and he's part of sales. So I'm going to put him in the sales VLAN, right? So that level of flexibility has to be there. The next two layers are very important: automation and analytics. So you should be able to automate a lot of things in your network, right? There is no point in doing the same set of things again and again. So you can actually save some time and spend that time to improve your network, right? Design a new network or help your business grow, right? And the analytics part, we talked about the visibility, right? So absolutely no visibility. We don't have much visibility of what is happening on the network, what is the user experience, unless the user calls and tells us. And then the last layer is about the management. So you should have a centralized management that will manage everything. Now, of course, the all surrounding everything is now a security is more important, right? So security is no longer a perimeter discussion. It is no longer, if you have a greatest firewall or IDS, IPS, that's not enough. So you need to have the network infrastructure do first level of security itself, right? So you should be able to do some kind of detection saying that, okay, is this, secure traffic? Is this something that is, completely not seen? So those kind of behaviors that network can detect and correct, right? Or at least raise the alarm. So this is the architecture framework that we came up with 3 years ago, and most of our solutions have been around this. And it is easy to put this in place when you are doing something new. That is, you are setting up a greenfield network, greenfield site, a new building coming up. You can look at all these factors and say that, okay, I will build my network for all these layers. So, but for the brownfield, the ones that you have, set up in the last 5 years, 10 years, what do, right? So that also can be put into this DNA model, but you have to work at it uh, very slowly, right? So when the current infrastructure is aging and it comes for a renewal or refresh, that's when you will start putting those layers in place, right? But a suggestion is that if anything new that you're going to build, please use this framework to build your network. So having said this, now let's get into intent-based networking. Intent-based networking is nothing but use of uh, this DNA framework, right? So what we talked about in the previous slide, it is that framework, um, to do it intelligently. So what we do is we have the network, that now can be controlled by a server, right? So there is a software that runs, and it becomes, we call it DNA center, right? So DNA center becomes the control point for your entire network. Now, what does that DNA center do? Is actually it takes your business goals or intent and says that, okay, I need to configure the network in such a way. You don't have to remember the commands, right? So you can say, okay, this is the traffic which is WebEx, or this is video traffic. This is business critical. All that you need to tell the DNA center is that this is a business critical traffic, and then it will set up the entire network configuration to make sure that the SLAs are honored, the QoS policies are in place. You don't have to log in to switch by switch to do it, right? So this is what it does. And the second thing is there is a feedback loop, right? So from the network, you start listening, you start learning, saying that what is happening in real time, and then be able to take correct decisions, be able to do proper troubleshooting quickly. Right? So this is what is the intent-based networking is translating your intent into configurations or network configurations. So program the network as per the right intent of your business. Right? So that is what is intent-based networking, and this is becoming very popular these days. And this is now endorsed by analysts like Gartner and IDC. They're tracking the usage and adoption of IBN or intent-based networking. So that is the first part of the story, right? So what is IBN? Why do we need it? So this is where we get into the second part. So we get into what are the key things that have happened and what are the key concepts, and then what are the innovations that we can do. So as I said, you have the regular network, right, which consists of your switches, routers, wireless LAN controllers, access points, all that stuff, infrastructure devices. But then these devices are now managed by a server called DNA Center Appliance, or sometimes it's called DNAC appliance, DNAC, right? So DNAC is nothing but a server. It sits in the data center, and it runs a software called DNA Center, which can be accessed through a web browser, right? So you can sit on your laptop and then access the DNA Center interface, and you can do a lot of things like you can do a design, you can do a policy, provision, assurance. The only other component that is outside of the DNA Center is the Cisco Identity Services Engine. That's a radius server that sort of facilitates the identity-based networking, right? So you need to know before you authenticate, before you allow somebody on the network, you need to authenticate using .1x, and then make sure that you know who's the identity. Is it an IoT device, or is it a laptop? Is it a mobile phone? Is it an iPad? So that kind of identity check is done, and then it will push the policies or push the saying that, okay, this is Ved from sales logging in through his mobile phone. He will have this kind of access. So that port gets programmed for that particular access only. I can't go and talk to finance or whatever that restriction that you may have. So it does the policy, it does the authentication, right? So that is what is the complete setup of a IBM. Now, um, when you have this kind of a software control point, right? When I say software control point, is like bringing in that server which will control all your parts of your network. Now, you can do a lot more things, and there are three things that we actually suggest, right? So we give you three options to do it. One is called automation. Automation is basically trying to do zero touch provisioning, software management, all this stuff, right? Compliance. Assurance is the visibility into the network and trying to be proactive instead of reactive on the network. And the third thing is the SD access or software defined access. It's a complete new way of, doing your access layer network with a lot of flexibility, a lot of security inbuilt. Now, in today's session, we will talk about only the first two parts, right? So we will not talk about the SD access because that itself is a separate topic for a different webinar. It will take a long time. So we will focus on these two things that you can quickly do with DNAC in place, right? So automation and assurance. Now, what is automation? So first is that you need to be able to make all the configuration changes, anything, any changes on the network, you can actually do it through the central software control point, right? So you don't have to log into every switch to do the change. You can do it from there and push the changes. So you can also do a lot of um, you know workflows, right? For example, we will talk about some of those to increase the productivity, right? So IT productivity, you can automate so many things that you normally do it manually. Okay, so these are the use cases for automation, right? So there are multiple use cases. There are certain use cases, what we call as day zero automation. So day zero automation is nothing but before you set up the network, right? So before you actually users come onto the network, right? So you're deploying a new network. So for that, you can use the plug and play. You can use the wireless automation. Uh, you can do standard change automation and a little bit of application policy, right? So these are all day zero automation. Even before the users start using the network, new setup coming up, you can automate a lot of these things. So day one to day n automation is like from the the time that users start using it uh, till you start um, till day n, that is forever. You keep doing certain things to improve the network. All that can be done also through application policy management, software image management, and RMA workflow. Now, what are these things? We will just quickly check. You know what happens. So, what is typically happen? This is a scenario, and this is Cisco IT also used to use this kind of a thing. On the top half, you see that you know you place an order for the equipment. The order gets uh, shipped to a staging site, right? So it gets shipped to, and it is meant for a new site that is coming up, but it gets shipped to wherever the expert is or the network engineer sits. Now he does the staging, he configures everything, and then he ships it to the new site where it needs to be deployed. And when he ships it, there is also a technician that goes with it so that he will go and plug it properly, power it on, and then make sure everything is fine. The users come on board. He will stay for 2 3 days, make sure that there are no issues. Then he comes back. This used to be the older process. Now what happens is with the DNA center plug and play, you can actually order the equipment, get it shipped to the site directly, and use the DNA center because you can actually have standard templates created in DNA center. When the device is plugged in, there it just needs to be powered on and network needs to be connected. You can actually program the device from the DNA center, which is sitting in your main site in a data center. Right? So this leads to almost about 50% OPEX savings, um, compared to the older way of doing things. So this is the day zero automation that you can do with plug and play. The next one is the software image management, and this is a big headache for most IT teams because what happens is when you run into a first of all, the good practice is to keep all your switches, all your routers uh, using the same standard of iOS, right? So all your um, so all your switches should be on a access switches should have one standard iOS image. This helps in actually running the network smoothly. You don't run into a bug and then you troubleshoot and then find out that that switch has a different iOS. Others are not having that problem. So there is a whole. So Cisco recommends to have that standard image across all your switches, similar switches, and keeping that standard image is a Herculean task, right? So we actually, we have every 3 months or 6 months or every year you have to go and upgrade those devices. And if you're a global company, then it's a huge task. Now this can be totally automated because DNAC can start pushing those software images, and it can actually not only just pushing is just a simple thing. Distributing the software is not a big thing. Many tools do that, but be able to do the pre-check validation and to go through the CR or change request process and do a post check, right? Post deployment validation also. So this is all the workflows that are built into the software image management using the DNAC. So very useful, and especially when you have a large network. The other thing that you can actually start doing is start doing the N+1 rolling AP upgrade. So if you have a lot of APs, then how do typical scenario is like you have to upgrade the software on the controller and the APs. It's 3 4 hours downtime. So is there a better way to do it? So there is a rolling AP upgrade that we devise where you can have another controller at a different site using the already upgraded. So you can actually start selecting certain APs and without impacting. Because when you select certain APs, it will be like 5% or 10% of the APs, not all of the APs. So you'll identify and start upgrading those APs. And when those APs are upgrading and rebooting, the other APs in the neighborhood can actually step up their step up their power and cover that area, right? So there is no outage for the user as such. And then so the APs get upgraded and move to the older or the previously upgraded controller, and then you can upgrade the primary controller and then move the APs back to it. So this is like zero downtime type of um, scenario where you can do your API. The other innovation is actually on the enterprise QoS is a big thing, and you actually uh, this is where the manual configurations gets defeated, because if you have, let's say, uh, a CEO of the company doing a video conference with the biggest customer of that company, and you want to make sure that your QoS settings are perfect and prioritized for that session only, right? So that is a 1 hour session, that is only, and then after that it should be rolled back to business as usual. So this scenario was not never possible uh, earlier, because this the trying to put QoS on different types of devices itself is a big challenge, right? Uh, so we have different types of hardware, different type of queuing, and because of that, you can if you start putting CLI based configurations everywhere, it takes a long time to address even the part of the flow, right? So it will take a couple of hours to do it, and then rolling it back is again um, at the end of the session is another major challenge, right? But here, if you have that software control point, which is the DNAC, right? So DNAC can actually push those configurations to the devices which are in the path, and then at the end of the hour, right, end of the session, it can roll it back, right? So without any um, intervention at all from the operator. This is what the network programming gives you that flexibility. And this is like implementing QoS in minutes, and you don't have to learn about all the QoS complexities of number of queues, number of you can actually the hardware dependent QoS configurations are quite complex. You don't need to get into all this stuff. The DNAC does the interpretation for you. You just say that this is my intent, and this is the business critical traffic for next 1 hour. So I remember that before this type of thing, when Narendra Modi was the chief minister in Gujarat, and he used to have video conferencing with all his, the IAS officers in each district, uh, or the ministers, then people used to shut down everything else. All the other servers, desktops were all down. Right? So this was about 10 years ago. I'm talking about. Um, then for that 1 hour or 2 hours, and then they would reboot it. This was to make sure no other traffic disturbs this video conference. But now we don't have to do all that kind of measures. We can actually use the DNAC to program the network on the fly. The other workflow or innovation that you can say is basically on the RMA side of it, right? So RMA is that when there is a faulty switch and you call in Cisco for replacement, right? So this send you a replacement switch or a replacement router. Now this is where there is a lot of manual work to make sure that that router is configured properly or that switch is configured properly, and then it is inserted at the right place and there is no disturbance to the existing network. All this workflow can be divided or actually put on the DNAC, right? So it can be moved into the DNAC, and the hardware replacement, it does all the backend work of, whether how to change the device in ICE. So you need to change it in Identity Service Engine because you have introduced a new device. You have to upgrade or replace the certificate. You have to copy the license, whatever is relevant from the old device to the new one. So in the DNAC inventory, it gets replaced, and so whatever the key trends were captured for the older device, that continue, saying that okay, instead of this device, I'm now using this device, so I'm not going to lose all the information that that was there for the last device. Okay, this will be a continuation of that device. So this is the kind of a smooth RMA workflow that has been introduced. So those were some examples of the automation part. Now let's look at the assurance or the visibility part of it, right? So visibility part is that, to say that what we have done in the last 3 years is actually, earlier we used to rely only on SNMP for visibility of the device. Now we look at so many other parameters also. We collect so much information, including syslog, netflow, SNMP, um, trace route, whatever information that, we have some 16, 17 parameters that we look at, we collect all that information and we bring it to the DNAC. And it's not just SNMP protocol, but it's also multiple protocols or new protocols like telemetry and other stuff that we do that. Now, what is what is that we achieve? Because the once you have so much information, then you can do all kinds of correlation of that data within the DNAC, right? So there is an analytical engine that runs, and then it will correlate and bring you some useful insights about the health of the network, right? So first thing is, what we do is we bring in the client visibility. So till now, earlier the network stock is it a switch? Is it a PC or a Mac or is it a laptop? What is it? We don't care about it. But now we start measuring the client experience, right? So we look at it saying that how long is it taking for the user to get authenticated on the network? How long is it taking him to get a DHCP IP address? How long is it taking him to actually do a DNS lookup and be functional? So all this parameters we start measuring and saying that, client health is good or bad. So on a scale of 1 to 10, we can say that client health is 7 out of 10 today, which is a improvement from yesterday, which was 5 out of 10. And the reason being, okay, DHCP server was responding very slowly. So we can actually, we can have that level of granular visibility, and we try to max out on whatever is the data that has been collected, right? So client visibility is one big thing that is new. Then we have the wired and wireless devices, right? So we look at the device health, right? So these are the infrastructure devices or network devices which are looking at it. So we look at their health, saying that, okay, my devices are in good health. Yesterday it was 8 out of 10. Today it's 9 out of 10 because two APs were down yesterday and they came back, we replaced them. So that health score is available. Uh, Anybody from, the network engineer all the way up to the CIO, he knows that, okay, what is my health of the network? And if it goes down to 5, he knows that there is a big problem, right? Then, the other thing that is new is application visibility, right? So we start looking at the application. So earlier, if you look at any network management, we used to look at only the device part of it, right? CPU is good for the router, memory is fine, all that stuff. But now we are looking at the client and we're also looking at the application, right? So application, is it performing good, bad? What is the health score of that, right? So this is what is the, the key understanding of assurance. Assurance is the deep visibility that we provide. Now, this is just an example of, let me just build this slide quickly and talk about it, saying that, okay, if you had a uh, uh, wireless poor experience on wireless from a client or a user, end user, and so there was on the left side you see, how much time it took to actually address. This is just an indication because it may vary from side to side, from skills of the network engineer to troubleshoot. All this may vary. Now, this is it could easily take about 200 minutes or about 200 minutes, which is like three hours plus, because it may need somebody to go to that site as well to do some kind of a manual, check on the signals, wireless signals. Now, because there is a lot of automation, and we also use something called active sensors. I will talk about it a little bit. So this, troubleshooting sitting in one place, you can finish in 20 minutes and try to solve the problem. Right. So this is a This is the advantage of having that rich data collection and visibility of the network. Now, another beautiful thing that uh, you know, and probably all of us have experienced this at some point or later, at some point or other, that there is a network issue, and suddenly everyone is getting logged out, and then everyone logs in after two minutes, everything is fine, and nobody is able to say what happened at that point. Right? So why we were logged out? Why was there an outage? Nobody is able to do it. You call Cisco TAC. TAC says, okay, sir, you have to collect these logs, and you fix collect these logs next time it happens, and then we will look at it to say, okay, what is the problem? How can we fix it? So this is like waiting for the next time same thing to happen. Now, since we collect so much information from the devices, now we are able to actually recreate that information going into the past. This is what we call as network time travel. The network time travel is a feature where you can actually um, you know just use a slider and you move that slider to 3 hours before. 3 hours before, you will exactly see what were the devices, not just that particular device or wireless line. Every device, whether it was a router or a switch or firewall or whatever that is actually how was it functioning? Was there a CPU problem? Was there a memory issue? Was there a some kind of a wireless interference at that point in time? So you can actually move back in time. You don't need to wait for the things to happen again, and you can actually um, you can go back up to 14 days. You can do this kind of visibility of the network. So you go back. So you would look at the health scores at that time, what happened. But not only that, so once you have that information, you can always look at it from future point of view also, and say that, okay, hey, I see that CPU is going up steadily from 60% to 70%, 75%. So you can say that there could be a problem developing now, right? So you can be proactive in in some way. And you can also see that if there are so many people logging in from home, like how it is today, right? So what would be the problem, right? So is that a capacity problem? How can we eliminate that? So you can do some kind of extrapolation of that. So that is called network time travel. The other user thing that we have introduced is called the active sensor. Active sensor is nothing but a small device. It looks like your mosquito repellent, small one. You plug it into the socket. Now, what that does is actually it acts as a client. It acts or simulates a user. So, so far, if you look at the wireless, we stopped at the AP level. We said, okay, this is where our network ends. We know that it is a client issue, whatever. Right? So now we say that, okay, we plug in this. Now we can start simulating a user behavior, right? So he's logging into the network, he's getting authenticated, he's getting IP address, he's getting a DNS lookup, he's doing a DNS lookup, he's opening certain applications. So all this can be programmed on the sensor, active sensor, and instead of waiting for the user to complain, once you have deployed the sensor on a floor, then you can actually simulate all this stuff, and you can simulate it multiple times, right? So you can run this kind of tests multiple times during the day. So the users come in during peak time, then again during the afternoon, then at the end of the day, and you can see how they, what is the behavior and what is the experience of the user, right? So this is another good thing to have. Now you can do the active sensor, and that active sensor will give all its information to the DNAC. Other small innovation that we have done is we have been in the last 3 4 years we have been working with Apple, and we have been working with Samsung. Now on the Wi-Fi part, right? So the mobile devices, what they can, so they have a special handshake between Cisco access point and the Apple device, Apple iOS, or the Samsung, right? So Samsung device. So what happens is there's a special handshake that happens, and because of which they are able to recognize each other. Now the Apple device or the Samsung device is able to give a lot more information about the client or the user experience to the DNAC, right? So we are able to collect that information. And also we are able to prioritize certain applications from the device itself, right? So earlier QoS would start only where the network point is, like access point onwards. There was no way to prioritize on the device itself, on the client device. Now we have pushed the QoS down to um, these devices that we've been working with. And of course, we have long list of Microsoft and a few other vendors that we will be working with. So there is a lot of engineering work that is going on. I talked about the business critical applications, so assurance. So we monitor so many applications based on our N bar 1400 applications we're able to recognize and see what is that performance of that. How is the packet loss? How is the network latency? How is the jitter? And all these parameters are measured and reported back. So we have real-time visibility of saying that okay, SAP is running slow right today, and then we can so instead of user complaining and we pointing fingers to the server team or application team, we can now look at proactively saying that is it because of the network? If network is fine, then we can go back and tell the server or application team saying that look, there is no problem in the network. This could be something on your side. So the and very recently what we have done is that once we have so much information, right? So we have collected so much information, we have done so many things. Now what we do is we also take our knowledge base, right? So we have 30 years of knowledge base of Cisco TAC. We also have we have so many um, you know sorry about that. So we have so much information collected that we can actually use the artificial intelligence, right? So artificial intelligence or AI, we call it AI ML and machine learning. So AI ML engine runs in the cloud, and what we can do is we can say that we can set the baselines, right? So custom threshold. So saying that okay, let's say CPU usage of 60% is normal for a company, right? So company A, but for company B, 60% may be too high, right? So it may be 40% of CPU usage is what is their normal. So that difference between company A and company B, so you can't say that anytime it is above 40% is a problem. So you reduce those kind of false alert um, that you actually start doing this, using AI ML. You can start looking at the customized thresholds, right? So you can drive the dynamic baselines for alerts for that particular company based on their history, based on their past performance, right? So this is another new addition that we have done. Now that is about the automation, and that is about the assurance or the visibility part. Now look at the DNA Center platform itself, right? So we look at the DNA Center. We're saying okay, it can manage the network devices. It can also collect information and do some intelligence, bring some intelligence and visibility of what is happening on the network. But that is not enough, right? So you need to have the right. Okay, so this is more about the the platform, right? So when we talk about the platform, it is about how do we integrate into the other systems, right? So how do we do that? And whether the platform is built for scale or not, right? So whether it can scale up to a large network. How is that performance? So little bit about the DNA scaling itself. So large appliances. So earlier we had only one type of DNAC, right? So we had only one server, one type of server, and we told that this is going to be the only one that you can use. Now, what happens is now that we have three types of DNAC. Uh, you know, Based on your needs, we can suggest which one. Like T-shirt sizes, you have regular, large, extra large. It depends. The regular has 44 cores, and it can handle 25,000 endpoints. 56 core is large, and 112 cores is the 100,000 endpoints. It's the largest one. So we have different, and we have the scaling with ICE, right? So whether we have multiple DNACs, how does it integrate with one single ICE cluster, and uh, one single DNAC, can it talk to multiple ICE clusters? So that kind of flexibility in terms of bringing that authentication and policy engine tied up with this. The other aspect is the DMS. The DMS is nothing but more of saying that it's a manager of managers, right? So if you have, let's say, a large network and you have so many DNACs in your network that are monitoring and configuring and working with so many devices, I have a centralized visibility of all the DNACs, right? So the manager of manager comes in and it becomes a DMS system. So these are some of those innovations. So there is also always one more question saying that can I use a DNAC on the cloud, right? So this is also a possibility we are looking at, and we have started few trials in the US, and very shortly later this year in our region we will have um, DNAC on the cloud. It may not have all full functionality that we talked about because that's where you need that processing power, right? So it will have some bare minimum capabilities of the DNAC on the cloud. So that is definitely a possibility. Now, not only about the scale, but also look at the programmability and integration of the DNAC with various systems, right? So you can have the DNAC itself talking to northbound APIs, right? So you can have like a web page or a dashboard, which will collect information from DNAC and it will show. You can customize your own IT portal, showing all the statistics about availability and all that stuff. You can pull information from the DNAC. You can also have uh, notifications via webhooks, saying that okay, is there a problem? Can I open a ticket automatically? Right. So I detect there is a problem, there is a slowness. I open a IT ticket, and so there is an integration with ServiceNow. Right. So um, now also with other IP address management tools. Right. So Infoblox or BlueCat, we can have that integration with Tableau for reporting. And then the developer enablement, right? So you can actually have certain SDKs that you can start playing with, right? If and this is where it gets interesting because network and programming, it starts uh, uh, you know uh, intersection of network and programming. Now these are some of those that we already talked about, right? So instead of manually doing that human middleware, you remove, and you can start directly 2 3 systems talking to the DNAC itself, and taking advantage of the programmability part of it. So there is also a concept of southbound device pack, right? So we talk about saying that okay, there is always this question of saying that okay, all this works with Cisco network, Cisco devices, right? So but will it work uh, with other vendor devices also, right? So whether it's HP, Juniper, Huawei, whatever you have, because many customers have a multi-vendor network, right? So they have so so it is possible. So that is possible through something called device packs, right? So device packs are the interface of this is how the DNAC interprets, what kind of device that it's talking to, network device it's talking to. So the device packs for Cisco is already there because you don't have to do anything. But device packs for other vendors, the SDK, you can use the SDK to develop those devices. And some of our partners, you know, already they have developed certain device packs for HP Aruba and few other vendors, right? So it is not completely impossible that how much integration is possible with non-Cisco devices. We're not completely ruling out, but there is a possibility of integrating non-Cisco devices also into the DNAC platform. This is another innovation that we want to push. And last but not the least is the DevNet site, right? What we call as developer.cisco.com. If you have not been to this site, I would highly recommend that you go into that developer.cisco.com site, and here you can actually learn about the programming aspects of the DNAC, uh, as well as many other Cisco products. Right, so all the API documentations are there. There are labs, there are sandboxes for you to practice, and so we are in a state where there is a intersection of programming and intersection of network. Right, so earlier network was all CLI based, but if you the way things are moving, right? So people, there is, if you ask me, the highest paid, professionals, IT professionals in the US today are what called DevOps or NetOps or SecOps. So these are the guys who actually can understand the systems and then they can integrate, make sure that the operations are smooth, right? So there is not much manual work, so you're automating a lot of things. So, so DevNet, or we call it DevNet, is the branding of this entire thing. Developer.cisco.com is the way, is the place to go and pick up your skills on the programming side. There are a lot of tutorials, free tutorials. All you have to do is register, and you can go through that classes. Now, having said that, I just wanted to, this is not related to any of the innovation, but this is where the industry is headed, right? So all of us are familiar with CCNA, CCNP, and CCIE type of professional certifications, right? So it's been there for ages, and it's been very popular. People learned a lot going through these programs. But because now the programming is a key aspect, this is where the software certifications are also coming up. So when you go to the DevNet site or developer.cisco.com, you can also chart out your way to becoming a Cisco certified DevNet associate, DevNet specialist, DevNet professional, and of course, in future we will have the DevNet expert certification as well. So this is something good because that's where the industry is moving. This is where the skill sets are supposed to be. So this will be valued, right? So think about this. This is more of making you aware that where Cisco is headed also. So these skills, programming skills or software skills become important. Okay, so I'm on to my last slide, and this is where we talk about what is next. So for your digital journey, if you want to use the DNA Center um, and want to know more about it, right? So ask your account team, sales team, for a demo of Cisco DNA Center, right? So they can do that demo. Your systems engineer can talk to you and set up some time and then walk you through a complete demo. We can also do a free network readiness assessment. We can say that, okay, where are you right now and what does it take for you to bring in the DNA Center, right? So you need to just upgrade the software. Do you need to change few hardwares here, there? So we can do that kind of analysis. And also bring in the ROI type discussion, right? Saying that, okay, if you do this, this is where it, and we can also do a pilot of the DNA Center in a lab, right? So we can bring you into our labs and we can show you how it works, how it will work in your environment. So this is possible. And so the question now is about what is um, the cost of doing all this stuff, right? So the cost of it is nothing much. It is going to be the same what you spend, but what you will see over a period of time because of the automation, because of the assurance, because of the simplified troubleshooting, proactive stuff, your OpEx cost keeps coming down, right? So your CapEx hasn't changed, right? So your CapEx is still there, but your OpEx cost, what used to take a lot of effort to keep it running, it comes down because you are now doing a lot of things in an automated way, and you are proactive in nature. That's how the ROI works out for this kind of a DNA type of setup, right? The digital network setup. So with that, I will stop here and I will switch over to the questions. I hope this session was relevant and we covered all the things that you were expecting. But I will now I will go to the question and answer part. Stop sharing. Okay, so first question is Cisco DNAC Spaces an extension of this model? So Cisco DNA Spaces is what we call it. So DNA Spaces is an add-on to all this stuff, right? So DNA Spaces gives you visibility of how people are interacting uh, uh, with the physical space, right? So you have a physical space, let's say a store or a mall or a hotel, right? So through Wi-Fi, you will be able to actually sense saying that how many people are coming into that area, how long they're there, and how many times they're coming back in a week. So that kind of analytical information is available in the DNA Spaces, which is a separate add-on to this in the cloud, right? So it's a cloud-based thing. As long as you have the wireless LAN controller, you can point it to the wireless LAN controller to the DNA Spaces. We are also running some, I think, 60-day or 90-day promotion for DNA Spaces, so you can try it out. It's very useful, and in many cases, you can also see, especially in emergency situation like fire or some kind of where you have to evacuate a lot of people out of the building. You can still get a visibility of how many people are still in the building, where are they located, right? So that kind of visibility you will be able to see. So so it is just an add-on to this entire DNA space. So the key attributes of IBM is the question. So key attributes are basically automation. How can you automate things? Um, how can you get visibility of the network, real-time visibility of the network? That is one. Third is the how can you bring in more security into your network, right? How can you do segmentation on the fly? So these are the three things I would say: automation and analytics, and the visibility, and the security part of it. Is IBM the future of IoT? Is the other question. So IoT is is outside of IBM, right? So IoT is more and more devices becoming, you know, you are using it for automating a lot of things, right? For example, you have process automation. So process automation is generally done when you have a lot of sensors along the factory, right? So now those sensors are looking at sending data. Now, how can that data be customized? How can that data be analyzed and used for your own uh, you know optimization of the process? That is what is the IoT will bring in. But IoT will need some kind of a network to ride on. So, um, so IoT will need some kind of a network. It's a wired network or wireless network. So all these devices that are coming on, will transmit some data, and it um, has to go into the uh, has to go into some kind of a server at the back end, maybe in the cloud, maybe what we call as fog computing, which will first level of computing is done on the very close to the IoT devices, and then only certain information is sent out. So all this is possible. IoT will IBM is more about how do you make sure your network is ready for all these IoT devices, all types of mobility, and how can you automate, how can you do assurance, how can you do security on the network itself. So they are kind of related, but not completely dependent on each other. So I would say that. So any other questions, please? Please type in. We still have a few minutes, couple of minutes to go. Okay, so I don't see any other questions coming up. I think this has been good. So thank you for joining. Um, I know this is a time that you would like to learn and see what is going on. You get some time off from your busy day-to-day schedule. So this is good. That thanks for joining us, and I hope the session was useful and relevant to you. I had shared. Let me do this. I will share my um, contact details. I'll project the first slide again, and that's where I had my email ID. So in case you need to get more information, give some feedback, clarification, feel free to reach out to me, and then I can work with you. I can also engage a larger team to help you out. Uh, so we are here. We want you guys to actually start using these innovations and give us feedback as to what else you need. Right. So now, once you have the software control point, it becomes very easy to actually start doing a lot of things. So, so we would like to hear from you as to what are the things that we can actually start doing better, right? On these type of innovations, the workflows that you use. So with that, I will stop here. Thank you so much for your time, and hope to hear from you.
Thank you, Ved.
All right. Thanks everyone for joining. We will end this session now.